Welcome to a video on IV calculations using gravity flow. With gravity flow, the most common way that we do the calculations is using the formula where our rate, and that is the rate in drops per minute, is the volume times the drop factor, which can also be referred to as the set calibration, divided by the time. Now, keep in mind, our rate over here is supposed to be drops per minute. So the time is going to have to be the time in minutes. When we are dealing with milliliters per hour, our time is in hours because that's the label we want. But here we want a volume in drops and a time in minutes. The drop factor will take care of converting our volume to drops, and so that's why this little formula works. Let's take a look at several problems. And so our first one, we're asked to find four different things, and we're given just a few pieces of information about our IV. So total volume is given to us right here, 500 milliliters, so I can complete that question without any math. The milliliter per hour rate, well, I have the hours here, so I know that I just take the milliliters and divide by the hours, because those are the labels, and so 500 divided by 4 comes out as, let me do my calculator here so you see it, 500 divided by 4 equals 125 milliliters per hour. And the next thing that I'm going to need to do is the drop per minute rate. So this is the formula that we just looked at. So I know the rate here is equal to the volume, which is 500 milliliters, times the drop factor, which is also given to me right here. So 15 drops per milliliter. And this is exactly what I was telling you before. The milliliters cancel, so the drop factor acts like a conversion factor, canceling that label, changing our volume into drops. Now we have the time is 4 hours, but we need to convert that to minutes. So we do that by multiplying that by 60. I can do that one in my head. So 4 times 60 is 240. So in the denominator I put 240 minutes. Now I'm ready to go to my calculator. So I have 500 times 15 divided by 240 equals 31.25. Now because we actually count the drops, we need to round this to a whole number. And so I'm going to rate my drop per minute rate as 31 drops per minute. So 31 drops per minute. And last, the total time, and that was given to us before, so no calculations there, just filling in the information. So that's the most basic problem. Often the problem that the nurse encounters, because the nurse often wants to know just how fast to count for the drop per minute rate. In our workbook, we're going to have some problems that are looking at just a little bit more of the math, asking for some other variables in this formula. So let's take a look at one of those. Again, we have the same four questions, but they gave us different pieces of information. So I'm going to just go through and fill out as much information as I can. So first piece of information, 450 milliliters is the total volume. Milliliter per hour rate is not given, and the hours are not given, so I'm not able to calculate that just yet. Drop per minute rate is given, so that's 25 drops per minute. And the time is not given, so we're missing that piece. So because we have a drops per minute given, we're going to use our formula. So for the rate, we are given that rate. So 25 drops per minute equals volume of 450 times the drop factor, which is 20, divided by the time, remembering that the time is in minutes. So I just have a little bit of algebra to solve this. I'm going to make it into a proportion by putting this over 1 and cross multiplying. So on this diagonal we get 25t equals, and so on this diagonal I have 1 times 450 times 20, so let me go to my calculator. 450 times 20 should give me 900, but just doing the math to show you, excuse me, 9,000. So equals 9,000. And then divide both sides by 25. And again, I'm going to do that right on my calculator. So take this, divide by 25 equals, and so the time is 360. You're like, well, wait, that would be minutes because our time is always in minutes over here. So in order to convert that to hours, I'm going to take it and divide it by 60. There we go. Time is 6 hours. So in my problem here, time is 6 hours. I'm just filling in my math. The time from our calculator was 360, so that we see that. That was the time in minutes. And so we divided by 60 to convert that to hours. And then we can figure out our milliliter per hour rate. So our volume is 450 divided by 6 hours. And again, we'll go to our calculator. So 450 divided by 6, and our milliliter per hour rate is 75 milliliters per hour. So equals 75 milliliters per hour. So we use the formula again right here. We use the formula a little differently this time because they ask us to solve for time, and we already knew the rate. Once we figured out the time, we were also able to calculate the milliliter per hour rate. So let's look at one more example. And for this example, again, we'll just start with the pieces that we know. So I'm looking to fill in any information that's in the problem. The IV is regulated at 30 drops per minute, so that means I know my drop per minute rate. Drop factor is 60 drops per milliliter. The IV will run for 10 hours. So again, I know a piece of information, total time. I don't know the volume, and I can't calculate the milliliter per hour rate until I know the volume. So I'm going to use my drop per minute formula. The rate is 30. The volume is unknown. The drop factor is 60. The time is 10 hours, but remember I need that in minutes. So I'm going to multiply that by 60, so that would be 600. So here is 600 minutes. Just like the previous problem, I'm going to put this over 1, and then I'm going to cross multiply. So multiply on the two diagonals. On this diagonal, we typically write the number first. So 60V is equal to, and then we need to do 30 times 600. So 30 times 600. So 18,000. We'll divide both sides by 60. So these cancel, and V equals, I'll go back to my calculator and type divided by 60, and V equals 300. So our total volume up here is 300 milliliters, and that gives us the piece of information that we need to do milliliters per hour. So we know that there are 300 milliliters in 10 hours, and we can do that math in our head, and that comes out to 30 milliliters per hour. Now, once again, I strongly recommend that you practice some of these problems so that you have a good sense that you know how to do them rather than just watching me do them. And here are very similar problems to the ones that we just did right out of your workbook. So I recommend pausing the video, going and practicing them, and making sure that you understand this concept before you move on.